Hi everyone. I hope everybody is doing good. Today we are going to work on complex numbers, and the objectives that we will cover in this concept is add and subtract complex numbers, multiply complex numbers, divide, and perform operations with square roots of negative numbers, solve quadratic equations with complex imaginary solutions. But before we start, please make sure you subscribe my channel and like the lessons. And if you have any questions, please comment below and I will try my best to answer it. Okay, let's go ahead and start. Complex numbers and imaginary numbers. So let's try this first. The imaginary unit is I. I is imaginary unit. And it is defined as like I is always like if you have a square root of a negative number, then that's I, where I square is equal -1. So the set of all numbers in the form of like a plus bi with real numbers a, b, and I is imaginary unit, this is called complex numbers. This is called complex numbers. Now this is the standard form of the complex number a plus bi. Now let's do operation on complex numbers. The form of complex number, like the standard form, like a plus bi, is like a binomial, a plus bx. To add, subtract, multiply complex numbers, we use the same method that we use for binomials. So this is a binomial. So like we add and subtract and multiply binomial, that's exactly what we are going to do with the complex numbers. And just make sure one thing for the complex number, if you have a negative square root, negative number in the square root, then this is I, the negative goes for I, and then you're going to have a 1, imaginary 1 right there. And if you have I square, this is equal to -1. Okay, so let's do examples. Example A is adding and subtracting. Let's do adding and subtracting first. So let me do adding and subtracting. Complex numbers. Example A is like, for example, we have 5 minus 2i parentheses plus 3 plus 3i parentheses close. So it's just a simple binomial that we are adding, right? So the parentheses has to go first. For the parentheses, you know this is positive and this is also positive. When you don't have a sign, it's positive. So when you have positive, actually you don't do anything because positive times positive is going to give you positive, positive times negative is going to give you negative. So nothing is changing here, but I still like to do those distributive properties here because this is positive and this one is also positive. So if you have just positive signs or negatives or any other signs, you just multiply. So positive times positive is going to give me +5. Positive times negative is going to give me -2i. That's why I said with the positive, it doesn't change anything. You just have to erase the parentheses. But if you have a minus sign here, then you have to be very careful for that. So I have a plus again, positive times positive is 3, positive times positive is +3i. You see, I just distributed like we usually do binomials. Now this is the parentheses are gone, everything else is good. Now you can tell this is an expression and I have, these two are my like terms, like 2i and +3i and my -2i, they are my like terms. So 5 and 3 are also the ones I need to combine them. So 5 has a positive on the right, 3 has a positive on the right, on the left, I'm sorry, positive 5, positive sign on left of 5. So excuse me, we always consider left side sign for that term. So 5 plus 3 is going to be 5, 6, 7, 8. And then you have minus and positives. It's going to give me subtraction, different signs you subtract, keep the sign of the bigger number. Bigger is 3, so I'm keeping that. You subtract, it's going to give me 1, and I still have that I there. So if you guys pay attention, this is exactly like a standard form of my complex number, which is right there, a plus bi. So this is my answer for that one. It's I can do that one. This is my answer right now. Okay, let's do B. That's my another example. I have 2 plus 6i parentheses minus 12 minus I parentheses. Now you have to be very, very, very careful. Do you see you have a minus in the middle? So we have to be careful. On the left side, I have positive for that one, but I have minus for that one. So let's do the distribution carefully. I'm going to distribute positive times positive is positive. Positive times positive again is positive 6i. Now this is positive and I'm multiplying. Positive times negative is negative 12. Negative times negative is going to give me positive I. And if you check, do you see these signs changed? That's why I said when you have a minus sign, please be careful on that. Now all I have to do is combine my like terms. 2 and 12 gonna go together, so I'm subtracting. It's gonna give me, and keep the sign of the bigger, so it's gonna give me negative 10. Now I have to combine the 6i and 1i. You have imaginary 1, so that would give me 7i. So this is my answer for question or example B. There you go. Now let's try multiplying complex numbers. So I'm going to go multiplying complex numbers. Okay, let's do multiplying complex numbers. A example is 7i parentheses 2 minus 9i parentheses close. That's my first one. So if you check, it's multiplication, right? There is a multiplication sign between them, and the 7i is multiplying with everything inside the parentheses. So that's what I'm going to multiply. 7i times 2 is going to give me 14i. And if you pay attention, this was positive, it gave me positive. Now the next one, I'm going to do it. 7i times 9i, which is, and positive times negative is negative. We have to get the signs first, guys. 63, and I times I is I squared, right? And you already know I square is equal negative 1. I'm just going to write it here. I square is equal negative 1. So let's change this. I'm going to have 14th I minus 63, and I square means negative. So it's going to change 14th I positive 63. And you can tell this is my standard form of my complex number. So we are good right there. If you want to rewrite it, because you know the constant a plus bi, like the standard form looks like a plus bi, so I can make the 63 first, like move them around. You see that? So it would be better to do it like in the way the standard form they write. Okay, let's do part B. 5 plus 4i parentheses times 6 minus 7i parentheses close. Now I'm multiplying everything, okay? So let's try again. 5 is going to multiply with 6, and both of them has a positive right there. So positive times positive is positive. 5 times 6 is 30, right? Then I'm going to multiply the same 5 with 7i, and this time the positive times negative is going to go negative. 5 times 7 is 35, and I have a I. There you go. Now I'm going to do 4 times 4i times 6, and positive times positive is positive, 24i. Then I have 4i times 7i, which means positive times negative is negative. 4 and 7 is 28, and this time I have I squared. Do you see the I and I multiply, they get squared? So this is what I got so far. Now all you have to do is combine all the like terms. So 35i and 24i are like terms, and this I square has to change. Okay, so let's try to change that first and also do the like terms, these ones. Excuse me. 30 is going to stay as a 30. 35 and 25, so 35 is a bigger number, keep the sign, and 35 subtract 25 is going to give me 11i. That one is going to go minus 28, negative 1, because I square is equal negative 1. Now you have to just solve that. It's going to give me 30 minus 11i plus 28. So 28 plus 30 is 58. And minus 11i. Now this is a standard form, so I'm just gonna leave it like that, you know, a plus bi, so that's a standard form. Okay, let's try next is conjugate of a complex number. Conjugate of a complex number. Conjugate of a complex number. Okay, now for the complex number like a plus bi, this is a complex number, a standard form, right? A plus bi, we define its complex conjugate to be, let's see, complex conjugate, I'm gonna write it down, okay? Complex conjugate to be a minus bi. Conjugate is when you change this sign. This is a plus bi, that's going to be a minus bi. The product of a complex number and its conjugate is a real number, right? If I have something like, for example, a plus bi, the product of standard complex number and the conjugate complex number, their product is a real number. When you do the multiplication, it's a binomial kind of thing. You multiply a with both of these, you're going to multiply bi with both of these. And let me solve this. So I got a squared, then I got minus abi, then I got plus abi, and I got minus b square and I square, right? So this is what I got. These two gonna cancel out, and I'm left with a square minus b square, and since I square is equal negative 1, which I'm going to do that, then I am getting a square plus b square. So this is what I'm getting. Like I said, the product of the complex number and its conjugate is a real number, so that's gonna give me a real number. Okay, now complex number division, how do we do? We did the addition, subtraction, multiplication. We also did some of the conjugate. We will do some more examples on conjugate anyway, and then we do division. Now in the division, the whole purpose of complex number division is to get a real number in the denominator. we multiply numerator and denominator of a complex number quotient by the conjugate of the denominator to obtain this real number. So that's why I was trying to explain how do we do conjugate. So let's do division. Divide complex numbers. Divide complex numbers. So like I said, the whole purpose of division is to get the real number in the denominator, and in order for us to do that, we have to multiply top and bottom with the conjugate of the denominator. So let's do examples, then it will make more sense. I have 5 plus 4i divide by 4 minus I. Now this is the denominator, right? I'm going to do the conjugate of the denominator. So you're going to multiply top and bottom 4 plus I over 4 plus I. So now you have to do the distributive property on the top and the bottom both. So I'm going to do 5 times 4 is 20. 5 times I is going to give me 5i. 4i plus or times 4 is going to give me 16i plus 4i squared. In the bottom, the same thing we do. 4 times 4 is 16. I don't have to tell you I'm doing distributive like the way we did that one. 4 times 4 is 16. 4 times I is going to give me 4i. And before we multiply terms, please multiply their signs. Then I have negative 4i, and then I have negative I squared. Now we have to fix the square part in the combining like terms. So I have 5i and 16i. The 20 doesn't have any like term, so I'm going to keep that. Then I have for 16 and 5 is going to give me 21i, and I still have this I square is going to be equal negative 1. So I have technically negative 4. In the bottom, 4i and 4i cancel out. I'm left with 16 minus, and since this is negative 1, it's going to turn positive. These two turn positive. So I have 16. Now 20 and 4 you subtract, and it's going to give me 16 plus 21i divide by 17. And you can rewrite this as a complex standard form, like it's going to go something like this. 16, you know, the 17 goes under 16 and 21i both. So 16 over 17 plus 21 over 17, and we have that I. So it looks like a standard form a plus bi. Okay, so let's do principal square root of a negative number. So I already explained, if you have negative number in the square root, then it means you have actually this. Make I as a negative, and then you have square root of b. So let's do some of the examples for this. I have negative 27 square root plus negative 48 square root. Now since these are imaginary numbers in the square root, so I'm gonna do I 27 plus I 48. Now we have to find the factors for 27. It's going to give me 9 and 3. That one is going to give me, what are the factors of 48? 48 is, what is the 48? 12 times 4, right? Yes, 12 times 4. And we can also get the factor of 12. I mean, I can do this in the next step. Now, in this step, if you guys pay attention, I is going to stay I. 9 is a perfect square, so it's going to go 3i, and you have a square root 3 stays there. In this case, I do know that 4 is a perfect square, it's going to go 2i, and I still have that 12. Okay. In the square root, if you have something that you can factor further out, then please do that. Like 12 has a further factor, it's going to be giving me 4 and 3, right? And I still have that. I'm going to keep everything else as it is, because This side is done, we can't do anything there. Now in this case, I have 3i square root 3 plus, you know, 4 is a perfect square, so it's going to go outside. So 2 times 2 is going to give me 4i, and then I'm left with square root 3. Now these are when you have similar numbers in the square roots, under the square root, and you have, like, do you see the I is like, I'm thinking of like a variable, so they are the same, so they are technically like terms. So I'm going to add 4 plus 3, which is going to give me 7i in the square root 3 state. So that will be my answer for this question. Okay, so this is how this is gonna go. Let's do one more example for this imaginary number square root. I have -2 minus square root -3, and everything is whole squared. So the first thing first, you know, this one is going to change. So I have -2, and I do one step at a time. Please don't try to do several steps at the same time. Okay, so this is going to give me square right there, and the square means I have these two like a binomial, exactly the same, right? So I'm going to make it -2 minus I square root 3. I got 1, and I have this exactly the same, the other one, like this. Now you do the binomial distribution, like -2 and -2 and -2 and I square root 3. So let's try. -2 times -2 is going to give me positive 4. -2 in negative is going to turn positive, and this is going to give me 2I square root 3. Now let's try, these two goes together, negative times negative is positive. It's going to give me 2I square root 3. Negative times negative again is positive, and I got I squared, and since square root 3 times square root 3 is going to give me 3, because when you do square this, you know, square and square root are opposite operations, so I'm left with 3. So now I have the stuff, I have 4. These two are like terms, so that will give me 4I square root 3. This one is a -1. This portion is -1, right? So I get -3I. I'm sorry, not I, because I simplified that like -1. So I got -3, right? 4 subtract 3 is going to give me 1, and I still have 4I square root 3. So that would be my standard form, and it does look like a standard form. Okay, let's try the last thing I told you guys, quadratic equations. Quadratic equations with complex imaginary solutions. So for example, I have a quadratic equation, ax squared plus bx plus c equals 0. A, b, c are all real numbers. So when we solve the quadratic equation, we use, this is the equation that you guys have to memorize it. Positive negative b squared minus 4ac over 2a. Now b squared minus ac, I'm going to write it down, b squared minus 4ac is called discriminant. Discriminant. If the discriminant is negative, the quadratic has no real solution, okay? If discriminant is negative, then quadratic has no solution. And quadratic has no solution. Okay, if discriminant has no real solution, and what else? Quadratic equation with negative discriminant have two solutions that are complex conjugates. Okay, so let's try that. I'm going to give you an example for this. I have x squared minus 2x plus 2 equals 0. And I'm going to solve this using my quadratic. So this is actually a, b, and c. Okay. So let's plug in x equal b, negative b. So the negative sign stays and b is my negative 2. So you know this is going to turn positive 2. Positive, negative, then I have b squared, which means negative 2 times negative 2 is going to give me 4. Minus 4, a is 1, and c is positive 2. There you go. In the bottom, 2a, which is 1. There is invisible 1 here, so that's a. This is what I got. So now let's solve this. I have 2 positive, negative. Solve inside first. 4 times 2 is 8. 4 subtract 8 is going to give me, let's do this. And then I have 2 in the bottom. So 4 subtract 8 is going to give me negative 4, right? And I have divide by 2. Now, since it's a square root, has a negative number, then we need that I. So it's going to give me I, and you know 4 is a perfect square, so it's going to give me 2. Divide by 2. Now, since we need that standard form, so you can rewrite this 2 positive negatives 2 I 2. So you know they cancel out, these two cancel out, so I'm left with 1 positive negative I. Right? This is what it is. So the solutions are complex conjugates. The solution set is this too. The solution set is 1 plus I, comma 1 minus I. So that's my solution set for the quadratic equation. So anytime, I mean, if it's a simple quadratic, you can easily solve by factoring. But if it's something, but I mean, I would prefer always use my quadratic equation because I don't have to try over and over whether I'm getting answer or whether I'm not. So it's going to be a complex number if you are not, it's not a simple quadratic equation. Guys, if you have any questions, please comment below. I will try my best to answer it. If you don't understand anything in this video, please comment below too. I will explain it again. And please like my lessons and subscribe. Thank you so much. Bye.